You want the AI to answer from your contracts and your decks, not from the entire internet. Here's the trick that actually makes it do that. Here's why it can't yet. The model has read a huge slice of the public web, and it will happily talk about almost anything. But it has never seen your master services agreement. It has never seen the pricing deck your team rebuilt last quarter, or the 300-page policy binder your operations run on. So when you ask it a question about your business, it does the only thing it can. It reaches into its own memory, the patterns baked into its weights during training, and it makes its best guess. Sometimes that guess is fine. Sometimes it's a confident, well-written answer that is simply wrong because the real answer was never in there to begin with. There are two ways out of this, and the entire episode comes down to choosing between them correctly. So let me set up the one question we're going to answer. When you want a model to work from your own files, do you hand it the whole document, or do you teach it to go fetch only the parts it needs? Get that choice right, and the AI becomes genuinely useful on your data. Get it wrong, and you either blow your budget or lose the answer in the noise. Let's start with the fetch approach because it has a name you've probably heard thrown around. RAG, retrieval-augmented generation. It sounds like jargon. The idea underneath it is almost embarrassingly practical. Here's how it works. You take your documents and you cut them into pieces. A paragraph here, a section there. Each piece is called a chunk. Now, for every chunk, you run it through a model that turns the text into a list of numbers, a long string of coordinates. That numeric fingerprint is called an embedding, and the beautiful thing about it is that chunks about similar ideas end up with similar numbers. Two paragraphs about your refund policy land near each other in this number space, even if they use completely different words. You store all of those embeddings together in what's called a vector index. Microsoft, describing its own version of this, says the index holds billions of these mathematical representations. Then a question comes in. What's our cancellation window for enterprise contracts? That question gets turned into an embedding too. And now the system does a similarity search. It looks through the index and pulls out the handful of chunks whose numbers sit closest to the questions. Just the few most relevant passages. It takes those passages, staples them onto your question, and hands the whole bundle to the model with, effectively, one instruction. Answer using this. The model isn't guessing from memory anymore. It's reading the exact clause you pulled out of your own contract and summarizing it back to you. This isn't a new trick, by the way. It goes back to a 2020 research paper from a team led by Patrick Lewis, who gave it the name. Their insight was that a model has two kinds of memory. There's the knowledge frozen into its weights. Call that what it learned. And there's an external index you can search on the fly. Call that what it can look up. Combine the two and you get, in their words, more specific and more factual output than the model could ever produce from its weights alone. The modern version. Chop the docs, embed the chunks, search a vector database, is just the productized industrial form of that same idea. Now hold that in your head because there's a second approach that looks like it makes all of this unnecessary. It's called the long context window. The context window is just how much text you can show a model in a single go. Everything you type, everything you paste, plus its answer. And these windows have gotten enormous. 200,000 tokens. A token is very roughly about 3/4 of a word, so we're talking about hundreds of pages you can drop in at once. So the tempting thought is, why bother chunking and embedding and indexing anything? Just paste the entire document into the window and ask your question. No pipeline, no vector database, dead simple. And for one document, that instinct is exactly right. If you're working on a single contract, a single report, the thing that's open on your screen right now, paste it in whole. The model sees all of it, catches connections across the whole thing, and you skip all the machinery. For that job, long context wins, and it isn't close. But watch what happens when you try to scale that up to your whole company. Two problems bite hard. The first is money. When you stuff 100,000 tokens of context into a request, you get billed for all 100,000 tokens. Every single time you ask a question. Ask it 50 times today. You paid for that mountain of text 50 times. Retrieval, by contrast, pulls maybe a few thousand tokens per question. Just the relevant chunks, even if the library behind it holds millions of documents. At scale, That gap has been measured at something like a 1,250-fold difference in cost. That's not a rounding error. That's the difference between a tool you can afford to run all day and one you can't. The second problem is subtler and, honestly, more surprising. You'd assume that if you give a model more context, it can only get more accurate. Worst case, it just ignores the extra. Not true. There's a well-documented effect people call context rot. A model advertised with a 200,000 token window is reliably sharp only through, in practice, the first 40 to 80,000 tokens or so. Push past that and it starts to lose the thread. It misses details buried in the middle. It gets distracted by material that has nothing to do with your question. And here's the finding that ties it together. When the slice of genuinely relevant text is small compared to everything you've pasted in, below roughly 1 part in 5, retrieval consistently beats stuffing the whole thing into the window. Less, aimed well, beats more, dumped in. So the answer to our one question turns out to be beautifully clean. And I'll give you the verdict now, and then show you how the real tools line up behind it. For the single document you're actively working on, long context, paste it in, done. For a big, growing body of knowledge you'll question again and again, retrieval, every time. And the industry has stopped treating this as a religious war. The 2025 and onward consensus isn't pick a side. It's route between them. Send the small, focused job to long context and the big library job to retrieval, automatically. Which brings us to the part you actually care about. How do the tools on your desk do this? And which one wins for a company? Start with Microsoft Copilot, because this is its home turf. Copilot grounds on your files, meaning it anchors every answer in your own documents rather than its training memory. And it does it natively, inside your own tenant. Your tenant is your company's private, walled-off space in Microsoft's cloud, where no outsider can reach. Copilot does this with two pieces working together, something called the Semantic Index and the Microsoft Graph. It has already built that vector index we talked about across your SharePoint, your OneDrive, your Exchange Mail, and your Teams messages. Microsoft is explicit that this is retrieval-augmented generation under the hood. And here's the part that matters for any real business. The retrieval runs as you. It's security trimmed, meaning it only ever pulls content you're already allowed to see. If you can't open a file in SharePoint, Copilot can't quietly surface it in an answer either. That combination, your data already indexed, permissions respected automatically, no pipeline for you to build, is Copilot's genuine moat. For grounding on the files a company already lives in, it starts from a position none of the others quite have. Now Claude from Anthropic. And Claude gives us the single clearest proof that this whole framing is real, because it does both approaches and switches between them right in front of you. In Claude Projects, you attach a knowledge base, your PDFs, your documents, your spreadsheets. When that knowledge base is small enough, Claude just loads it straight into the context window. But watch what Anthropic says happens as it grows. When your project knowledge approaches the context limit, Claude seamlessly enables RAG mode to expand capacity by up to 10 times. Read that again. The product literally flips from long context to retrieval the moment your files get big enough to need it. That's not a debate anymore. That's the exact verdict of this episode, shipped as a feature. And Claude also plugs directly into where a lot of your work already lives, with add-ins for Excel, Word, and PowerPoint, and one in beta for Outlook. The other two do the same thing, just anchored to the suite you already pay for. ChatGPT from OpenAI comes at it from a few directions. There are straight file uploads, where your document rides along in the context. There are projects, workspaces that bundle your chats, your reference files, and standing instructions together. And there are connectors, sometimes surfaced as apps, that reach into Google Drive, Gmail, SharePoint, Dropbox, and more. On the enterprise tier, that becomes real search and retrieval over your indexed data. Its deep research mode works across everything you've connected. A quick honesty note here, one I'll repeat for Gemini. A plain upload behaves like long context, while the connectors in the enterprise search behave like retrieval. OpenAI doesn't publish the guts, so the precise mechanism is best described as retrieval style rather than stamped and confirmed. Same pattern, Google's side of the fence. Gemini does the same move inside Google Workspace. Ask Gemini in Drive and it grounds its answers on your Drive, your Docs, your Gmail, and tellingly, it cites its sources, a telltale sign that it's looking the answer up in your files, not reciting it from training memory. Plus, the same big context window for chewing through a single, long document. Same honest caveat. Google frames it as grounded, retrieval style. They don't hand you the architecture diagram either. Step back and the field rhymes. Every serious tool now grounds on your data, and every serious tool is quietly converging on the same answer we reasoned our way to. Small and focused goes to the context window. Big and static goes to retrieval, and the smart systems route between the two so you never have to think about it. So here's your decision, cleaner than any spec sheet. If the job is the one document open in front of you, the contract you're redlining, the deck you're finishing, hand the model the whole thing and let long context do its simple, powerful work. If the job is your company's standing knowledge, the hundreds of policies, the years of contracts, the whole shared drive you'll interrogate again and again, you want retrieval. And inside the Microsoft world, Copilot gives you that grounding natively, on your own tenant, with your permissions already respected. Big static library, retrieve. Single live document, paste it in. And the living proof that this is the right line is sitting inside Claude, which draws that exact line for you automatically the second your files get too big to hold. That's the whole trick. It was never about a bigger brain, it was about giving the model the right page at the right moment. And if this is where retrieval finally clicked, Episode 6 is worth a look on your way out. Grounding is the strongest defense against hallucination. Because everything you just learned is exactly how a model becomes far less likely to make things up. But next time we go one layer deeper, into the piece that quietly makes all of this work. Those numeric fingerprints, embeddings, are the whole reason a machine can tell that two paragraphs mean the same thing, even when they don't share a single word. Next episode, how machines learn the meaning of words. I'll see you there.